Good evening, everyone. Good evening. Good evening. I welcome you all again to the NEET Elite. Hope all of you are doing great, having the good time at home. Well, people, if I'm audible and visible to everyone, hit the chat box with a thumbs up. Let me know if I'm audible and visible to everyone fast. Hello, Janan. Hi, Keshav. Hi, Priya. Hi, Akib. Hi, Darshni. Hi, Shaista. Hi, Suji. Hi, Hadi. What's up? Hello, Shahid. Hi, Yashwani. Hi Tariq, hi Ashwarya, hi Fatima, hello everyone, welcome to the session, welcome to the session. People, if I'm audible and visible to everyone, hit the chat box with a thumbs up, let me know if I'm audible and visible, yes? Wonderful, walaikum salam Midhat, walaikum salam. Yes Janan, now it's perfectly fine, yes. Yes Abdul Hadi, I'm going to sleep tomorrow, yes absolutely, yes I badly need it, I badly need it. Wonderful guys, great. Alright, as you all must be knowing, in the last session of the Redox, we started the N factor calculations, yeah? We talked about the N factor of ions, we talked about the N factor of salts, we talked about the N factor of acids, bases, few exceptions among them as well, yeah? We talked about everything. And people, in the today's session, we are going to talk about that N factor only in detail. In the today's session, we are going to talk about the N factor of different oxidizing agents, reducing agents. We'll see a lot of reactions, and I'll make sure you get to know how to calculate the N factor of all the substances, whatever will be given in your questions, yeah? Okay, so before starting the session, guys, let me introduce myself. As you all must be knowing now, my name is Wassim Sir and I'm your chemistry master teacher right here. And before starting, do like the video, share and subscribe at the same time so that everyone will get benefited out of these sessions, which I always say in the every session, yeah? Okay. People, before starting the N factor calculations, let me give you the brief idea about the Vedantu NEET Pro subscription. If you guys are getting enrolled in it, what all benefits you guys are going to get. Let me tell you, you guys are going to get 5,000 plus hours of live online teaching. Regular tests and assignments will be provided to you, which contains more than 10,000 questions. We have got 20 plus teachers with 5+ years of experience will be training you personally for the upcoming NEET 2021 as well as 2022, right? You have got the option to learn either in English or in Hindi. It's completely your wish to select the language, get trained by the master teachers of Vedantu, okay? And people, at the end, we are going to cover everything over here, which includes your micro as well as crash course, right? For the ones who are going to appear in the NEET in 2021, we have come up with 3 different plans, as you all can see. And on every plan right here, we have got 50% off. 1 month plan, after the 50% off, you guys are just getting it for 3.75k. 3-month plan, 11k. 6-month plan, 29k. And people, this 50% off is just valid between 20th to 27th of December, right? So all these 3 plans are valid for the ones who are going to appear in NEET in 2021, right? For the ones who are going to appear in NEET in 2022, we have come up with 4 different plans, and on every plan right here, we have got again the 50% off. Yes, 1 month plan after the 50% off, you guys are just getting it for 2.5k. 3-month plan 6.75, 6-month plan 14k, 12-month plan 32k. On every plan right here, you have got 50% off, and this deal is just valid between 20th to 27th of December. Yeah. So people, for the ones who are the droppers, again we have come up with 3 different plans, as you all can see. The 1-month plan after the 50% off, you guys are just getting it for 4.5k. 3-month plan 15.5k, and 6-month plan 41k after the 50% off. And again, this 50% off is just valid between 20th till 27th of December. Yeah. Now the point is how to get enrolled in it, how to get enrolled in it. Let me tell you, there's a link in the description box of the video. Just click on that link, use the coupon code as WSPRO. On using the coupon code of WSPRO, you guys are going to get 50% off on whatever plan you're selecting for yourself. Yes? Okay. Alright guys, so let me know in the chat box if you are super duper excited for this session. Let me know in the chat box if you guys are super duper excited for this session. Let me know fast, let me know fast, let me know fast. Let me know fast with the thumbs ups. Yes, Yashwant has come up with a quote: there is nothing impossible in the world, everything is possible, only you should separate the word impossible to I'm possible from your mind dictionary. Good evening. Good evening Yashwant, that was good. Yeah, great. Alright people, super duper excited for this session. Let me know in the chat box with the thumbs ups. Yes. Yes, General, I'll be replying to your doubt on the Telegram. Yes, I'll be doing that. I didn't get time from the last 3 days to see the Telegram also, okay? I'll see that tomorrow and I'll get back to you, yeah? Okay, so people, you are super duper excited for this session. That's actually wonderful. That's actually great. Okay, so Let's move on and let's go to one of the most important topics from the redox reactions, that is the calculation of n factor, which we started in the last session, and tonight we are going to continue that in detail, right? So let's get started with the calculation of n factor for the different oxidizing and reducing agents. How do we calculate the n factor of oxidizing and reducing agents, correct? First of all, I told you in the last session, why do we need n factors of different substances? People, in order to calculate the equivalent weight of any substance, we should know the n factor of substance so that we can divide the molar mass of the substance by its respect to n factor. Then only we can get the value of equivalent mass of the substance. Yes, that's something which we have already discussed. Now, in the today's session, let's get started with the calculation of n factor of oxidizing and reducing agents, okay? So people, few important things I would like to share with you, okay? And I hope you get them properly, because this forms your basics of the equivalent mass, redox titration and everything, right? See, first of all, I'm going to take a general reaction right here. Let's say I'm taking a reaction as A plus B, it gives A positive plus B negative. Let's say this is one general reaction which I have, okay? And I'm assuming right now this A and B, these are right now present in their standard states, in their elemental states, in their native states. And we have already discussed, whenever the element is present in its standard state, its oxidation state is taken as 0. So I would say the oxidation state of A right here is 0, the oxidation state of B right here is 0, okay? People, what is the charge present on this A right here? I would say the charge present on this A right here is +1. So its oxidation state is going to be +1, yeah? What is the charge present on this B negative over here? It's going to be -1. So I'll say its oxidation state right here is -1, yeah? Now people, if you'll actually have a look, is the oxidation state of A increasing or decreasing? The oxidation state of A is changing from 0 to +1. So I would say the oxidation state of A is increasing, right? And as we discussed in the last session, increase in the oxidation state is what we call as oxidation. So A right here is undergoing oxidation over here. A right here is undergoing oxidation right here, okay? And any substance which undergoes oxidation, as you all must be knowing now, we call that as the reducing agent, yeah? So A right here in this reaction is my reducing agent, yeah? Now people, at the same time, what about the oxidation state of B? During this reaction, is the oxidation state of B getting increased or decreased? Oxidation state of B is decreasing from 0 to -1, yeah? There is decrease in the oxidation state of B, and as you all must be knowing now, decrease in the oxidation state of the element is what we call as reduction. So I must say this B right here is undergoing reduction. B right here is undergoing reduction, and any substance which undergoes reduction right here in this reaction is what we call as oxidizing agent. So people, first thing I got to know which one among these two reactants is my oxidizing agent and which one among these two reactants is the reducing agent, yeah? Very, very simple. See guys, this is my reducing agent right here, and this is my oxidizing agent right here. Yes. Now how do we calculate their n factor? How do we calculate the n factor of different oxidizing and reducing agents? Very, very simple. N factor of oxidizing or reducing agent is always equal to number of electrons exchanged per mole of oxidizing agent or the reducing agent. Now the point is, how do we get to know that? How do we get to know how many moles of electrons are being exchanged by the oxidizing or reducing agent by 1 mole of it? How do we get to know that? For that, let me tell you one simple thing. Understand what I'm going to say. See guys, understand properly what I'll say. Can I call this 0 as the initial oxidation state of A? Can I call this +1 as the final oxidation state of A? Yes. Oxidation state of A is changing from 0 to +1. 0 is the initial oxidation state of A, +1 is the final oxidation state of A. If I'll ask you to calculate the change in the oxidation state of A, isn't it going to be final oxidation state of A, that is +1, minus initial oxidation state of A, that is 0. I'll take mod of it, the value will be coming as 1. So 1 I'll be calling as the n factor of A right here in this reaction, okay? This is the n factor of A. Simple. Change in the oxidation state you have to calculate, right? This 0 was the initial oxidation state of A, and this +1 right here was the final oxidation state A. what I did simply is I just calculated the change in the oxidation state of A, which is going to be final oxidation state of A minus initial oxidation state of A, and whatever is going to be the value of change in the oxidation state of A right here, that's equal to 1. This one I'll be calling as the n factor of A right here. If you got to know the n factor of A, so should I be calculating its equivalent mass as well? Definitely I can do that. How will I be doing that? I'll simply divide the molar mass of A by its respective n factor. I'll be getting the value of equivalent mass in grams. Absolutely, yes. Similarly, what about the n factor of this B right here? Can I call this 0 as the initial oxidation state of B, and this B is getting converted to B negative? Over here, the oxidation state of B is -1. So this 0 is the initial oxidation state of B, this -1 is the final oxidation state of B. If I want to calculate the change in the oxidation state of B, it's going to be final oxidation state of B minus initial oxidation state of B. Just take mod of it, value will be coming as 1, and this one is what I call as n factor of B in this reaction. Yes, this is what I'll be calling as the n factor of B in this reaction. And people, if you'll get to know the molar mass of this B, you can calculate its equivalent mass as well. You just have to divide the molar mass of this substance by its respective n factor. You'll be getting the value of equivalent mass in grams. Absolutely right. This was the case number 1, which I wanted you guys to understand. N factor of the oxidizing agent is simply change in the oxidation state of element right here. Change in the oxidation state of element right here. You just have to take mod of that, right? Yes, Karthik, I'll be coming on that as well. Just wait for some time. I just started from the basics, okay? Let's try to scale it up slowly. And tonight I'll be taking little longer session because tomorrow is Sunday, yeah? You're going to sleep till 11, I know that, yeah? Okay, moving on. Moving on, let me give you one more reaction, one more general reaction, so that you get to know this concept properly, so that you can master this concept properly, okay? See guys, understand, let's say I've got a reaction like this, a general reaction I'm taking, A2 plus B2 gives, let's say, twice A positive plus twice B negative. One general reaction I took right here, okay? One general reaction I took right here, okay? Now people understand what I'm going to say. See, let's assume this A right here is present in its elemental state, standard state, and this B right here is again in its standard state. If they are present in their standard states, I would say the oxidation state of A and B right here is 0, yeah? Now people, the A2 is getting converted into twice A positive. What is the charge present on this A right here? I would simply say +1. What is charge present on this B right here? I will simply say -1. Yes. Can I say the oxidation state of A is changing from 0 to +1? Absolutely. Is the oxidation state of A right here getting increased or decreased? Oxidation state of this A right here is increasing. Increase in the oxidation state is what we call as oxidation. So this A2 right here is undergoing oxidation. So it will be acting as a reducing agent. Yeah. At the same time, the oxidation state of B is changing from 0 to -1. So I would say the oxidation state of B is decreasing from 0 to -1. And whenever there is decrease in the oxidation state of the element, that substance undergoes reduction. And any substance which undergoes reduction, that's what we call as oxidizing agent. Yes. Now guys, understand what I'm going to say. See. If I need to calculate the n factor of this A2 right here, how will I be doing that? Can I say, just a second, can I say this is the initial oxidation state of A right here, this is the final oxidation state of A right here? Yes. So if I want to calculate the change in the oxidation state of A, change in the oxidation state of A is going to be final oxidation state of A, that is +1, minus initial oxidation state of A, that is 0. Yes, what is the value coming? Value will be 1. But we will understand, this 1 is the change in the oxidation state for one atom of A. But over here I have 2 atoms of A. Yes, the 1 over there is the change in the oxidation state for one atom of A. But I have 2 atoms, so I'm going to multiply it by 2. The value will be coming as 2. So I'll say the n factor of A2 in this reaction is 2. N factor of A2 in this reaction is 2. Yes, if you got to know the n factor of this A2 right here, you can simply calculate its equivalent mass simply by dividing the molar mass of A2 by its respective n factor. You'll be getting the equivalent mass of the substance. Yeah, absolutely. At the same time, if I want to calculate the n factor of this B2 right here, people, should I be calling this 0 as the initial oxidation state of B2? Should I be calling this -1 as the final oxidation state of B? Yes. Now people, if I want to calculate change in the oxidation state of B, it's going to be again final oxidation state of B, which is -1 minus initial oxidation state of B, that is 0. The value will be coming as 1. But right here, this one is the change in the oxidation state for one atom of B, but I have two atoms of B. I'm going to multiply it by 2. The value you're getting is 2. So I'll say n factor of B2 in this reaction right here is 2. Yes, if you got the n factor, of B2, you can calculate its equivalent mass. How you will be doing that? Simply by dividing the molar mass of this B2 by its respect to n factor, you'll be getting the value of equivalent mass. Yes. Now people, at the same time, one more thing I would like to share with you so that you won't get any sort of doubt while teaching you the actual reactions. Okay, one more important term I'm going to give you. Say, let's say I've got a reaction like this. Okay, let's say I've got a reaction like this. 5 times A2 plus 4 times B2, or let's keep it like this. Just a second. 5 times A2 plus 5 times B2, it gives, for example, 10 times A positive plus 10 times B negative plus 10 times B negative. Let's assume this is one balanced chemical equation. See what I'll be doing, guys. Remember, whenever you want to calculate the n factor of any reactant or product in a reaction, you have got nothing to do with these stoichiometric coefficients. Yeah? Remember one thing, whenever you'll be given with a balanced chemical equation, you'll have to do nothing with these stoichiometric coefficients right here. Understand, guys? See, I'm assuming this A right here to be in its standard state, so its oxidation state is 0. I'm assuming this B right here in its standard state, its oxidation state is 0. The oxidation state of A right here is +1. The oxidation state of B right here is -1. Is the oxidation state of A increasing or decreasing? Oxidation state of A is increasing from 0 to +1. If the oxidation state of A is increasing, I'll say this A2 right here is undergoing oxidation, so it will be acting as the reducing agent. Yeah. At the same time, is the oxidation state of B increasing or decreasing? Very simple. From 0 to -1, oxidation state of B is decreasing. Decrease in the oxidation state is what we call as reduction, and any species which undergoes reduction, that acts as the oxidizing agent. Yes, I told you, in order to calculate the n factor of substances in a reaction, you have got nothing to do with these stoichiometric coefficients. Right here. Now people understand. First thing, if I want to calculate the n factor of this A2 right here, first of all, I'll say this is the initial oxidation state of A, this is the final oxidation state of A. I'll simply calculate change in the oxidation state of A, and change in the oxidation state of A is going to be final oxidation state of A minus initial oxidation state ka mod. You'll get the value as 1, but this one right here, it is the change in the oxidation state for one atom of A, but right here I've got two atoms, so I'm going to multiply it by 2. So n factor of A2 in this reaction is going to be 2. Very simple. Yeah. Now people, at the same time, the oxidation state of B is changing from 0 to -1. So change is going to be final oxidation state, which is -1, minus initial oxidation state of B, that is 0. The change is going to be 1, but this 1 is the change in the oxidation state for one atom of B. But right here I have two atoms, so I'm multiplying it by 2. So this 2 is going to be the n factor of B2 in this reaction. People, if you got to know the n factors of different substances, you can easily calculate their equivalent masses. How you'll be doing that? Simply by dividing their molar masses by their respective n factors. Let me know in the chat box if you got the concept of n factor. Let me know in the chat box if you got the concept of how do we calculate the n factor of different oxidizing and reducing agents. Then only I can move on to the reaction. Give me the thumbs ups. 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 Yes. Yes. Let me know fast. No, Janan, no rule of that. Yeah. Yes. Wonderful. Great. Great, guys. Moving on. Thank you, Yashwan. Thank you. Moving on, guys. Let's move on, and let's talk about something interesting. Okay. People, there is something called as potassium permanganate. Yeah. KMnO4. KMnO4. Just a second. this KMnO4, it acts as the oxidizing agent. It acts as the oxidizing agent. KMnO4 acts as the oxidizing agent. And in different mediums, it shows the different reactions. Remember, your KMnO4, either you write KMnO4 completely or you write MnO4 negative. One and the same thing, okay? Either you write KMnO4 or you write MnO4 negative, one and the same thing. Remember guys, your KMnO4 right here, it will be acting as the oxidizing agent. If it is acting as the oxidizing agent, it is going to oxidize other and itself is undergoing reduction. Yes, if it is an oxidizing agent, it will oxidize others and itself will undergo reduction. Very simple, yes. Now people, this MnO4 negative, or you call it as KMnO4, in acidic medium, it gets converted to Mn di positive. In neutral medium, this MnO4 negative, it gets converted to MnO2. And in the basic medium, it gets converted to MnO4 di negative. You are not supposed to remember in which, MnO4 gets converted to this, that. No need to remember that. I just want you to remember its N factor right here. Remember, first of all, MnO4 negative, or we say KMnO4, in the acidic medium, it gets converted to Mn di positive. In the neutral medium, this MnO4 negative gets converted to MnO2, and in the basic medium, this MnO4 negative, or we say KMnO4, it gets converted to MnO4 di negative. Yeah. Now people understand. Now people understand. If I'll ask you what is the oxidation state of Mn right here, you'll say +7. Yes. If I'll ask you what is the oxidation state of Mn right here, you'll say +2. If I'll ask you what is the oxidation state of Mn right here, you'll say +4. If I'll ask you what is the oxidation state of Mn right here, you'll say +6, because I have taught you in detail how to calculate the oxidation states of different elements in a compound. Yes. Exactly. Medium will be given to us. Yes. Understand what I'm going to say. In acidic medium, oxidation state of Mn is changing from +7 to +2. Yes, oxidation state of Mn is changing from +7 to +2 in acidic medium. Right? So is the oxidation state of Mn increasing or decreasing? Oxidation state of Mn is decreasing. Decrease in the oxidation state is what we call as reduction. So I would say this KMnO4, this MnO4 negative right here is undergoing reduction. If it is undergoing reduction, that means it is acting like the oxidizing agent right here. Yes. Now people, I need to calculate the N factor of this MnO4 negative or KMnO4 in the acidic medium. How will I be doing that? Very simple. I'll simply calculate first of all, N factor of this MnO4 negative right here is going to be equal. Simply, this is the initial oxidation state of Mn right here. This is the final oxidation state of Mn right here. I'll calculate mod of change in the oxidation state of Mn, which is going to be final oxidation state of Mn minus initial oxidation state of Mn, that is +7. Yes, the value you'll be getting is 5, right? And 5 is the change in the oxidation state for one atom of Mn, and I have only one atom. So I'll say in acidic medium, the N factor of KMnO4, the N factor of MnO4 negative is going to be 5. Very simple. Yes. Now people, at the same time, if I'll ask you in basic medium, is the oxidation state of Mn increasing or decreasing? It's again decreasing from +7 to +4. +7 is the initial oxidation state, +4 is the final oxidation state. Now if I want to calculate the N factor of MnO4 negative in the in the neutral medium, what I'll be getting, I'll simply write magnitude of change in the oxidation state of Mn in neutral medium, that is final oxidation state of Mn minus initial oxidation state of Mn, that is +7. You'll get the value over here as 3, and 3 I'll be calling as the N factor of KMnO4 in which medium? This is the N factor of KMnO4 in the neutral medium. Yeah. Now what about the basic medium? In the basic medium, the same MnO4 negative, the same KMnO4 gets converted to MnO4 di negative. Yes. So oxidation state of Mn in the basic medium changes from +7 to +6. This is the initial oxidation state of Mn. This is the final oxidation state of Mn. What I'll be simply doing, I'll be simply calculating change in the oxidation state. Change in the oxidation state is going to be final oxidation state of Mn, that is +6, minus initial oxidation state of Mn, that is +7. You'll get the value over here as 1, and this one over here I'll be calling as the N factor of KMnO4 in which medium? In your basic medium. Very simple. Okay. So remember, from now onwards, your KMnO4, your MnO4 negative, its N factor in acidic medium is 5. Its N factor in neutral medium is 3. Its N factor in basic medium is equal to 1. Let me know in the chat box if it's clear to you, so that I can move ahead and talk about a few more interesting things right here. Yes. Yes. Let me know in the chat box. Do like the video if you got the concept. Yes. Let me know fast. I know, Yashwini, exactly. I get it, yeah. All right, guys. All right, let's move on and let's talk about few more interesting things, okay? See guys, I told you this KMnO4, it acts as the oxidizing agent. It oxidizes others, but itself undergoes reduction. Yes, it is the oxidizing agent. It oxidizes others, but itself undergoes reduction. Yes. Now people understand one important thing right here. I will give you few reactions and see how easily you can remember those reactions and you can calculate their N factors as well. Yeah, understand. Remember first thing, this KMnO4, in acidic medium, it converts Fe dipositive to Fe tripositive. This KMnO4 in acidic medium, it converts Fe dipositive to Fe tripositive. And people see how I'll be writing the reaction, and you will love to write these type of reactions. Very simple. See, I told you your KMnO4, or you can write as MnO4 negative, one and the same thing, okay? I'm writing MnO4 negative instead of KMnO4, yes? MnO4 negative, I told you MnO4 negative is a strong oxidizing agent. It converts Fe dipositive to Fe tripositive. Yes, how will I be writing the reaction? Understand. MnO4 negative, it converts Fe dipositive. In which medium? Acidic medium. This H positive represents acidic medium. Yes, MnO4 negative converts Fe dipositive in acidic medium into Fe tripositive. Yes, and we already know itself this MnO4 negative in acidic medium, it gets converted to Mn dipositive, and with this I'll write some water as well over here. This is the complete reaction. Yes. So was there anything to remember? Just remember one thing, your MnO4 negative converts Fe dipositive to Fe tripositive. In which medium? In acidic medium. That's what I wrote over here. MnO4 negative converts Fe dipositive in acidic medium to Fe tripositive, and itself gets converted to Mn dipositive. With this I'll be writing some water as well. Yeah. Yes. Now people understand. See, if I want you guys to calculate the N factor of this MnO4 negative right here, either you can calculate it simply. This is the initial oxidation state of Mn, and this is the final oxidation state of Mn. So from +7 to +2, what is the change? Change is 5. Or we already know in acidic medium, N factor of MnO4 negative or KMnO4 is 5. Yes, we already know this. We are not supposed to calculate it again and again. So remember, from now onwards, MnO4 negative, its N factor is going to be 5 in acidic medium. Yeah. Now people, if I'll ask you what will be the N factor of this Fe dipositive right here, first of all, you will say the initial oxidation state of Fe right here is +2, the final oxidation state of Fe right here is +3. Yes, the oxidation state of Fe is changing from +2 to +3. Yes, the oxidation state of Fe is changing from +2 to +3. If I'll ask you what is the change in the oxidation state of Fe, that is going to be final oxidation state of Fe minus initial oxidation state of Fe. The value you'll be getting as 1. So 1 is the N factor of this Fe dipositive right here in this reaction. Yes, if you got their N factors, you can easily calculate their equivalent masses. How? Molar mass of this divided by N factor, molar mass of this divided by N factor. You can easily get the equivalent mass. Yeah. Very simple. Now people, let me move on to one more reaction. The first reaction which I want you guys to remember, simple, the KMnO4, it converts Fe dipositive to Fe tripositive. Yes. Now people, one more. The same KMnO4, the same MnO4 negative, it converts oxalate ion. It converts oxalate ion to carbon dioxide in which medium? Again in acidic medium. Yes, it converts, the same KMnO4 converts oxalate ion into carbon dioxide. Yes, I am damn sure, I'm 100% sure you can easily write the reaction now. See, what I'll be simply writing, the KMnO4, or simply I can write MnO4 negative, it converts your oxalate ion. Yes, it converts your oxalate ion. In which medium? In acidic medium. To what? It converts oxalate ion to carbon dioxide, and in acidic medium we already know MnO4 negative gets converted to Mn dipositive, and with this Mn dipositive I'll write some water as well. So this is the reaction. So is there anything to remember, guys? Nothing to remember. You can easily make this reaction. Yes, and N factor of MnO4 negative or KMnO4 in acidic medium is always going to be 5. If I want you guys to calculate the N factor of this oxalate ion right here, can you do that? Absolutely you can do that. Absolutely you can do that. See guys, first of all, if I want you guys to calculate the oxidation state of this carbon right here, you can calculate it. 2x minus 8 is equal to -3. You will get the value of x as +3. So this +3 is the oxidation state of carbon in this oxalate. Yes, what about the oxidation state of this carbon right here? Isn't it going to be +4? So I can simply say oxidation state of carbon is changing from +3 to +4. Yes, oxidation state of carbon is changing from +3 to +4. This is the initial oxidation state of carbon. This is the final oxidation state of carbon. People, if I want you guys to calculate the change in the oxidation state of carbon, you will say final oxygen state of carbon minus initial oxygen state of carbon, just take mod of it, the value will be coming as 1. But let me tell you, this one is the change in the oxidation state for one atom of carbon, but I have two atoms of carbon, so I'm multiplying it by 2. So n factor of oxalate ion in this reaction is going to be 2. If you got the n factor of oxalate, you can simply calculate its equivalent mass. How you'll be doing that? By just dividing its molar mass by its respective n factor. Yeah, very simple. This was our second reaction. People, the third reaction at the same time, the same KMnO4, it converts I negative to I2. It converts I negative to I2. So you can easily form the reaction. I can simply write MnO4 negative. It converts I negative in which medium? In acidic medium. To what? It converts I negative to I2 and itself gets converted to Mn di positive, and with this I'll write some water as well. First thing, you already know the n factor of MnO4 negative in acidic medium. We already know that is equal to 5. Now people, if I want you guys to calculate the n factor of this I negative right here, you can simply do that. Absolutely. See, the charge present on it is -1, the charge present on this is 0. Yes, so from -1 to 0, what is the change in oxidation state? Change in oxidation state is going to be final oxidation state minus initial. Value you are getting as 1, and we have got only one ion of this iodine right here, so 1 is the n factor of I negative right here in this reaction. If you got the n factor of this iodine right here in this reaction, you can calculate this equivalent mass. And how you'll be doing that? By just dividing the molar mass of this substance by its n factor. Yes. Let's move on to one more reaction. Remember guys, the same KMnO4, the same MnO4 negative, it converts H2S. It converts H2S in which medium? In acidic medium. It converts H2S to what? It converts it to sulfur, and itself gets converted to Mn di positive, and with this Mn di positive I'll be writing some water as well. Yes, absolutely. Yes. So first thing, the n factor of this MnO4 negative over here in this reaction is 5. Yeah. In this reaction is 5. We know the n factor of MnO4 negative, the n factor of KMnO4 in the acidic medium, that is 5. If I want you guys to calculate the n factor of this substance right here, people understand. See, first of all, what is the oxidation state of this sulfur right here? It is -2. What about the oxidation state of this sulfur right here? It is 0. So the oxidation state of sulfur is changing from -2 to 0. If I want you guys to calculate the change in the oxidation state of sulfur, isn't it going to be final oxidation state of sulfur minus initial oxidation state of sulfur? Just take mod of it. You'll get the value as 2. And I have only one sulfur atom right here, so 2 is the n factor of this H2S right here in this reaction. Yeah, very simple. Yes. Let me know in the chat box if it's clear to you. Fast. Yeah. Wonderful guys. Moving on to one more reaction. Remember the same KMnO4, the same MnO4 negative. It converts your hydrogen peroxide. It converts H2O2 in acidic medium. To what? It converts it to O2, and itself we already know it gets converted to Mn di positive, and with this I'll be writing some water molecules as well. And first thing, we already know the n factor of MnO4 negative in the acidic medium. Isn't it going to be 5? Absolutely. If I want you guys to calculate the n factor of this hydrogen peroxide right here, people, in the last session we talked about the oxidation state of oxygen in peroxides, which is -1. Yes, the oxidation state of oxygen right here is -1, and oxidation state of this oxygen right here is 0. The oxidation state of oxygen is changing from -1 to 0. If I want you guys to calculate change in the oxidation state of oxygen, isn't it going to be final oxidation state of oxygen minus initial oxidation state of oxygen? The value you'll be getting as 1. But people, remember, this 1 is the change in the oxidation state for one oxygen atom, but right here I have two oxygen atoms, so I'm multiplying it by 2. So the n factor of hydrogen peroxide right here you got in this reaction as 2. So 2 is the n factor of hydrogen peroxide right here. Yes, very simple. Okay, now people, moving on, and let's talk about this reaction as well. Let me tell you, the same KMnO4, it converts Sn di positive to Sn plus 4. Just you need to remember, it converts Sn di positive to Sn plus 4. You can easily write the reaction. I can simply write the reaction. Your MnO4 negative or KMnO4, it converts Sn di positive in acidic medium into what? It converts it into Sn plus 4, and itself we know in acidic medium it gets converted to Mn di positive. With this Mn di positive, I'm writing water as well. Now people, as you all must be knowing, MnO4 negative, its n factor in acidic medium, we already know that is 5. What about the n factor of this 10 right here? Its oxidation state right here is +2. Its oxidation state right here is +4. So from +2 to +4, what is the change in oxidation state? Isn't it going to be final oxidation state minus initial oxidation state? The value you'll be getting is 2. So the n factor of Sn di positive right here in this reaction is 2. Let me know if it's clear to everyone. Fast. Let me know in the chat box if it's clear to you. Just hit the like button if you got it. Hit the like button if you got it so that I can move ahead and talk about few more interesting things right here. Yes. Let me know in the chat box if it's clear to every single guy right here. Yes. Yes. Till then I can have some water. That's wonderful. If it's clear to everyone, that's actually great. That's actually great. So let's try to move on. Just a second, guys. Just a second. Just a second. Yeah. Let's move on. Let's move on. Let's move on. Let's move on. And one last reaction of KMnO4. You can easily kill it now. Okay. You can let me know. You can let me know the reaction. You can let me know the reaction. Very simple. Yes, Afra, you have to remember these reactions. Absolutely. You don't have to remember. You just remember this KMnO4, it converts Fe di positive to Fe tri positive, I negative to I2. Similarly, Sn di positive to Sn plus 4, H2O2 to O2, and similarly SO2 to SO4 di negative. Then you can easily write the reactions. Yeah. Very simple. So I can say the same KMnO4 or the same MnO4 negative, it converts what? It converts your SO2 in which medium? It converts your SO2 in acidic medium to what? It converts it to SO4 di negative, and in acidic medium we already know it gets converted to Mn di positive, and with this I'll be getting some water as well. If I'll ask you what is the N factor of this MnO4 negative right here, you'll simply say N factor of this KMnO4, N factor of this MnO4 negative right here is 5. Yes. Now people, at the same time, if I'll ask you what is the oxidation state of sulfur right here, you'll say plus 2. If I'll ask you what is the oxidation state of sulfur right here, you say plus 6. Okay, so if I'll ask you what is the change in the oxidation state of sulfur, isn't it going to be final oxidation state of sulfur, which is plus 6, minus initial oxidation state of sulfur, which is plus 4. The value you'll be getting is 2. So 2 is the N factor of SO2 right here in this reaction. Yeah, very simple. Now people, moving ahead, now talking about the one more oxidizing agent, that's what we call as K2Cr2O7. Yes, K2Cr2O7. Again, it acts as the oxidizing agent. Again, it acts as the oxidizing agent. Yes. Remember guys, K2Cr2O7, either you write K2Cr2O7 or you write Cr2O7 dinegative, one and the same thing. Yeah. Remember, in your acidic medium, your Cr2O7 dinegative, or I'll say simply K2Cr2O7, it gets converted to Cr plus 3. It gets converted to Cr plus 3. Okay. So first thing which I want you guys to remember right here. See, what is the oxidation state of this chromium right here? You can calculate it. 2x minus 14 is equal to minus 2. X is equal to plus 6. The oxidation state of this chromium right here is plus 6. What about the oxidation state of this chromium right here? Plus 3. So can I say chromium is changing its oxidation state from plus 6 to plus 3? Okay. Should I be calling this as initial oxidation state of chromium? Absolutely. Should I be calling this as final oxidation state of chromium? Absolutely. If I want you guys to calculate the N factor of this potassium dichromate, N factor of this Cr2O7 dinegative ion right here, what it's going to be all about? It's going to be magnitude of final oxidation state of chromium, which is plus 3, minus initial oxidation state of chromium, which is plus 6. You'll get the value as 3. But this 3 is the change in the oxidation state for one atom of chromium. But right here I have 2 atoms, so I'm multiplying it by 2. So its N factor is simply going to be 6. So remember, N factor of your Cr2O7 dinegative, it's going to be 6. Yeah, it's going to be 6. Number 1. Number 2, whatever reactions we saw for KMnO4, same reactions, this Cr2O7 dinegative, same reaction, this K2Cr2O7 dinegative is going to show. Okay, if you remember, your MnO4 negative, your KMnO4, it used to convert Fe di positive to Fe tri positive. Similarly, your Cr2O7 dinegative, it's going to convert Fe di positive to Fe tri positive. Similarly, it will be converting Sn di positive to Sn plus 4. Similarly, it will be converting H2O2 to O2. Similarly, it will be converting SO2 to SO4 dinegative. Similarly, it will be converting I negative to I2. Okay, and reactions we can easily write. How will I be writing the reactions? I think I should write all the reactions in just a single page. Yeah, is that should I be doing that? Okay, let me write it like that. First of all, this Cr2O7 dinegative, this K2Cr2O7, it converts Fe di positive to Fe tri positive. Yeah, see guys, first thing, your Cr2O7 dinegative, it converts what? It converts Fe di positive in acidic medium to Fe tri positive. And just now we saw Cr2O7 dinegative in acidic medium, it gets converted to Cr plus 3, and with this Cr plus 3 I'll be writing some water as well. This is your complete reaction. Yeah. Now people see, We already know the N factor of your Cr2O7 dinegative in acidic medium is 6. So no need to calculate it again. Remember it as 6. What about the N factor of this Fe positive right here? +2 to +3. Change in the oxidation state is 1. So its N factor is 1. Yes. And at the same time, people, we know Cr2O7 dinegative, it converts I negative to I2. It converts I negative to I2. So I can write the reaction right here only. Cr2O7 dinegative, it converts I negative in which medium? In acidic medium to what? To I2, and itself gets converted to Cr plus 3. And with this, I'll be writing some water as well. Yes. N factor of this is 6. N factor of this will be -1 to 0. That means its N factor is 1. Done. Yes. Very simple. Okay. Similarly, let's move on to few more. Oxalate ion to carbon dioxide. So you can easily write the reaction. I'm damn sure about that now. So people, I can simply say the Cr2O7 dinegative, or I can say K2Cr2O7. It converts what? It converts your oxalate ion, which is C2O4 dinegative, in which medium? In acidic medium. It converts it to carbon dioxide, and itself gets converted to Cr plus 3. And with this Cr plus 3, I'll be writing some water as well. Yeah, very simple. So people, very simple. Yes. See guys, what about the N factor of this Cr2O7 dinegative over here? It's going to be simply 6. We saw that. Yeah. What about the N factor of this oxalate ion right here? Oxidation state of carbon right here is +3. The oxidation state of carbon right here is +4. +3 to +4. The change is 1. 1 is the change in the oxidation state for 1 atom of carbon. But I have 2 atoms of carbon. So its N factor is going to be 1 multiplied by 2. That means 2. Yeah. I can calculate the equivalent mass as well. Correct? Now people, talking about few more reactions, we know Cr2O7 dinegative, it will convert again SN di positive to Sn plus 4. Whatever reactions your KMnO4 was showing, same reactions it's going to show. Yeah, you can easily do that. Yes. Very simple. So people, can I say it like this? Cr2O7 dinegative, it converts what? It converts Sn di positive in acidic medium to what? It converts Sn di positive to Sn plus 4, and itself in acidic medium, we know it gets converted to Cr plus 3, and with this Cr plus 3, I'll be writing water as well. Yeah, you can write the N factors. N factor of this right here is 6. N factor of this is going to be +2 to +4. Change in the oxidation state is 2. So its N factor right here is going to be 2. Yes, you can write the same reactions again and again. Let me know if it's clear to everyone. So that I can move on to few more interesting things right here. Correct? This reaction we have written. This reaction you can easily write. The same reaction which KMnO4 showed. Yeah. Even this reaction we wrote in the beginning. Yeah. Even this reaction we wrote. This reaction you can also write. What is the reaction going to be? Reaction is going to be simply Cr2O7 dinegative plus SO2 plus H positive gives SO4 dinegative plus Cr tri positive plus water. The reaction is done. Yeah. Okay, now people, one more interesting thing. People, there are certain substances which sometimes behave as the oxidizing agent, sometimes behave as the reducing agent. Yeah, there are few substances which sometimes behave as oxidizing agent and sometimes behave as reducing agent. Yeah, and your H2O2 hydrogen peroxide is one among them. Okay. See guys, understand what I'm going to say now. See, your hydrogen peroxide is one of the substances which sometimes acts as the oxidizing agent and sometimes acts as the reducing agent. Let's check right here in this reaction what it is acting as. Let's check it out first. Let's check it out, and then we'll calculate the N factor as well. We'll get to know its equivalent mass as well. Everything is in front of you. Everything I've taught you in detail. You can easily kill these questions now. See guys, if I'll ask you what is the oxidation state of this oxygen right here, this is H2O2 hydrogen peroxide. In case of hydrogen peroxide, the oxidation state of oxygen is -1. What about the oxidation state of this oxygen right here? It's -2. Absolutely. See, -1 to -2. Is the oxidation state increasing or decreasing? From -1 to -2, oxidation state is decreasing. Yes, decrease in the oxidation state is what we call as reduction. So in this reaction, your H2O2 is undergoing reduction, and if this is undergoing reduction, in this reaction, it will be acting as the oxidizing agent. Yes. If I want you guys to calculate its N factor, this is the initial oxidation state of oxygen right here. This is the final oxidation state of oxygen right here. If I want you guys to calculate the change in the oxidation state, which is going to be final oxidation state minus initial oxidation state. Yes. Just a second, guys. final oxidation state minus initial oxidation state. The value you're getting as 1. This 1 is the change in the oxidation state for one oxygen atom, but right here I have 2, so I'm multiplying it by 2. So the N factor of hydrogen peroxide right here in this reaction, when it is acting as the oxidizing agent, it's going to be 2. So I want you guys to remember this. Yes, this is the reaction which H2O2, which hydrogen peroxide is going to show when it's going to act as the oxidizing agent. Yes, very simple. Now people, at the same time, the same H2O2, it can act as the reducing agent as well if it is acting as the reducing agent. First of all, in this reaction, it will be acting as the reducing agent. How you will be identifying that? Let's get to know that. Over here, we have got hydrogen peroxide. What is the oxidation state of oxygen in hydrogen peroxide? It's -1. What about the oxidation state of oxygen right here? It is 0. Is the oxidation state increasing or decreasing? From -1 to 0. Oxidation state is increasing. Increase in the oxidation state is what we call as oxidation. So right here in this reaction, H2O2 is undergoing oxidation. If H2O2 is undergoing oxidation, so right here in this reaction, it's going to act as the reducing agent. Yes. Now people, very simple. Very simple. What is the change in the oxidation state of oxygen right here? Isn't it going to be final oxidation state of oxygen minus initial oxidation state, which is -1? So the change in the oxidation state of one atom of oxygen, it is going to be 1. But right here, I have 2 atoms of oxygen. I'm going to multiply it by 2. The value you are getting as 2. So I'll say N factor of H2O2 right here when it is acting as the reducing agent is also 2. So remember, if H2O2, if hydrogen peroxide acts as the oxidizing agent, or if it acts as a reducing agent, in both the cases, its N factor is going to be 2. Let me know in the chat box if it's clear to you so that I can move ahead and talk about few more wonderful concepts. Yes. Yeah, Janan, you can do that. You can do that. Why not, bro? You can do anything. Ayush, you can take the video a little back, bro. It will be automatically a replay of the video, okay? Yashwant, I'm getting better, bro. Yes, moving on, guys, moving on. Few more interesting things right here. I'm going to give you questions. Let me see if you can answer these questions or not. This is the first question over here. Calculate the N factor of the following. So right here, I want you guys to calculate the N factor of I2 over here. You can calculate. So basically, I want you guys to calculate its equivalent mass. Equivalent mass is molar mass divided by N factor. If you know its N factor, you can divide its molar mass by its N factor, right? Very simple. You can easily kill it now, guys. The oxidation state of iodine right here is going to be 0. The oxidation state of iodine right here is going to be +5. Yes, you can calculate it. I have taught you in detail. What about the change in the oxidation state? Just have a look. Oxidation state of iodine is changing from 0 to +5. Yes. What about the change in the oxidation state of iodine? Isn't it going to be final oxidation state minus initial oxidation state? Value is going to come as 5. But this 5 is the change in the oxidation state for one atom of iodine. But over here I have 2 atoms. So I'm going to multiply it by 2. So the N factor of I2 right here in this reaction is 10. Yes. Now people, if I want you guys to calculate the equivalent mass of I2 right here, it's going to be molar mass of I2. Molar mass of I2, as you all must be knowing, that is 254 grams per mole divided by N factor is 10. So its equivalent mass is going to be 25.4 grams. Very simple, yeah? Yes. Yes. Very simple, right? Okay, one more question, guys. One more simple question. I want you guys to calculate the N factor of this N2H4 right here. You can easily do it, correct? Let's calculate the oxidation state of this nitrogen right here. Isn't going to be 2x plus 4 is equal to 0? Isn't x value coming out to be -2? So over here, oxidation state of nitrogen over here is -2. 2x plus 4 is equal to 0. So 2x is equal to -4, x is equal to -2. The oxidation state of nitrogen right here is -2. What about the oxidation state of nitrogen over here in this compound? Hydrogen will show +1. Yes, let's assume the oxidation state of nitrogen is x plus oxygen is going to show -2. And how many oxygens we have? 2 oxygens. Is there net charge present on the molecule? No way, right? It's going to be -4 plus 1. -4 plus 1 means -3. So x is equal to +3. So over here, the oxidation state of nitrogen is +3. The oxidation state of nitrogen is changing from -2 to +3. What about the change in the oxidation state of nitrogen? It's going to be final oxidation state of nitrogen, which is +3, minus times initial oxidation state of nitrogen, which is -2. The value will be coming as minus plus. The value will be coming as 5. So 5 is the change in the oxidation state for one nitrogen atom, but over here I have 2. So I'm going to multiply it by 2. Again, it's going to be 10. So 10 is the N factor of this substance right here. If you got its N factor, you can divide its molar mass by its respective N factor. You'll be getting the equivalent mass. Yes, very simple. Okay, Now people, let me move on to one more question. Let me see if you can solve this or not. Very, very simple. I want you guys to calculate the n factor of this. Calculate the n factor of this IO4 negative right here. You can easily do that, okay? You can easily do that. You can easily see that, do that. Yes. What about the oxidation state of this iodine right here? You can calculate. This is IO4 negative. Yes. The oxidation state of the iodine right here is +7. The oxidation state of iodine right here is 0 because it's right now, it has got no charge on it. What about the change in the oxidation state of iodine? Isn't it going to be final oxidation state minus initial oxidation state? Final is 0. Initial is +7. Take the mod value, you'll be getting as 7. 7 is the change in the oxidation state for one iodine atom, and over here I've got only one. So n factor of IO4 negative in this reaction is going to be 7. If you got to know its n factor, you can simply divide its molar mass by its n factor. You'll be getting its equivalent mass. Very simple again, yeah. Moving on to one more. We have got VO changing to what? VO changing to V2O5. What is the oxidation state of V over here? It is +2. What is the oxidation state of V over here? It's going to be 2x minus 10 is equal to 0. X is simply equal to +5. Yeah. Very, very simple. Now people, I want you guys to calculate the n factor of this VO right here. +2 to +3. What is the change in oxidation state? Final oxidation state, which is +5, minus initial oxidation state, which is +2. Value you'll be getting is 3. 3 is the change in the oxidation state for one atom of V, and over here I've got only one atom. So n factor of this VO right here is 3. If you got its n factor, you can divide its molar mass by its respect to n factor. You'll be getting what? You'll be getting what? You will be getting the equivalent mass. Absolutely. Yes. Now people, one more. Okay, this is interesting, guys. You can calculate it as well. This is the non-stoichiometric compound. If you know, you would have discussed this in solid state as well. In the solid state, you get one pattern of questions in this form. Okay, I'm sure you would have studied that in your class 12 solid state. If not, I'm going to teach solid state soon, okay? So relax. Okay, first thing, guys, I need to calculate the n factor of this substance right here. How will I be doing that? First of all, I should know what is the oxidation state of this iron right here. Okay, I do not know that. So I'm supposed to calculate that. Yes. How will I be calculating that? Very simple. See, let's assume the oxidation state of iron right here is X. And how many iron atoms do we have over here? 0.94. Yes. What is the oxidation state of oxygen? That is -2. How many oxygen atoms do we have? Only one. Is there net charge present on it? No way. So can I say X value I got as 2 divided by 0.94? Yes. Can I say it's going to be plus 200 divided by 94? This is going to be my average oxidation state of this iron right here in this compound, which is going to be plus 200 divided by 94. Yes. What about the oxidation state of this iron right here? Isn't it going to be 2x minus 6 is equal to 0? So x is equal to +3. Yes. Oxidation state of iron is changing from here to here. Can I call this as the initial oxidation state of iron? Can I call this as final oxidation state of iron? I will just calculate change in the oxidation state of iron. I'll calculate change in the oxidation state of iron, which is going to be final oxidation state of iron minus initial oxidation state of iron. Yes. This is the initial oxidation state of iron. This value from here you will be getting change in the oxidation state for one atom of iron, but over here I do not have one atom. I have got 0.94, so I'm going to multiply this value as 0.94. Whatever value you are getting from here, that will be the n factor of this Fe 0.940 right here in this compound. Okay, so I want you guys to remember this as well. This term, only this term is going to give me the change in the oxidation state of iron right here, but I do not have one atom. This term is going to give me change in the oxidation state for one atom of iron, but right here I've got 0.94, so I'm multiplying it by 0.94. so whatever value you'll be getting, that is going to be your n factor. And remember, n factor you'll be getting as fraction over here. Okay, and n factor can be fractional as well. Remember that at the same time. Let me know in the chat box if you got the concept. Yes, exactly, Karthik. It'll be coming as 0.82. It'll be coming as 0.82. So from here, you'll be getting the value as 0.82. So n factor of this compound right here is the 0.82. Yes. Yes. Very, very, very simple. Fazan, you can go for Narendra Vastibo, bro. Yes. Yes. Hit the chat box, hit the like, bro, if you got it. Yes. Should I move on? Should I move on to a few more interesting things right here? Yes. I'm going to take your 15-20 minutes extra, guys. So, no, Zanab, those are not. Yes, you want me to take 15-20 minutes extra? You want me to do that? Janan, you can take the video a little back, bro. Yes, Yojana, you can write the doubts in the comment section afterwards when the session will end, yeah? All right, wonderful, guys. Let's move on. You people seem interesting, yeah? Wonderful, wonderful, wonderful. Okay. See, guys, now comes one more category right here. Till now, which substances we talked about? In all these substances, whatever n factors we calculated n factors of different substances, yes. And in all these substances, oxidation state of only one element was changing, yeah? Whatever n factors we calculated till here, oxidation state of only one element in a compound was changing, correct? Now we are going to talk about those substances in which oxidation state of more than one element will change. Now I'll show you how do we calculate the n factors of the substances in which the oxidation state of more than one element will change, okay? And in the category right here, what do we have? In the first category, we have this sort of a compound, n factor of the compound in which the oxidation state of more than one element increases or decreases, okay? See, guys, I have got a compound right here. I have got few compounds right here in which oxidation state of more than one element will be simultaneously increasing or decreasing, right? Oxidation state, let's say I've got a compound like this AB. I've got a compound like this AB. It is participating in some reaction, and I'm saying oxidation state of A as well as B is increasing during the reaction, or I'm saying oxidation state of A as well as B is decreasing during the reaction. So I'm going to talk about those compounds in which oxidation state of more than one element either increases or decreases, okay? There can be one more case also. Oxidation state of one element increases but other one decreases, okay? First of all, I am going to take that case in the compound in which oxidation state of more than one element either increases or decreases, okay? Let's see how do we do that. No, Karthik, it's not disproportionate, bro. Disproportionate we are going to talk about in a while, okay? Understand what I'll be doing. See, guys, understand properly, okay? First of all, if I want you guys to calculate the oxidation state of this iron right here, it is going to be simply +2. In the last session, we have talked in detail how to calculate oxidation state. If I want you guys to calculate the oxidation state of this carbon right here, isn't it going to be +3? Absolutely, yeah. What about the oxidation state of iron right here? It is going to be +3. What about the oxidation state of this carbon right here? +4. People, can I say this is the compound in which oxidation state of more than one element is changing? Yes, very simple. See, guys, from +2 to +3, oxidation state of iron is changing. From +3 to +4, oxidation state of carbon is changing. Yes, and oxidation state of iron is increasing. At the same time, oxidation state of carbon is increasing. So this is the example of the compound in which oxidation state of more than one element is increasing. Yes, how do we calculate n factors of these type of substances? Understand, guys, very simple. First of all, I'll calculate change in the oxidation state of iron, which is going to be final oxidation state of iron minus initial oxidation state. Final minus initial, come mod, you'll be getting the value as 1, or let me write in detail. Final oxidation state of iron is +3, initial oxidation state of iron is +2. Yes, you'll be getting the value as 1. So 1 is the change in the oxidation state of iron. I'll be calling this one as N1. I'll be representing it with N1 sign, okay? Similarly, guys, the oxidation state of carbon is changing from +3 to +4. So change in the oxidation state is going to be final oxidation state minus initial oxidation state. You'll be getting the value over here as 1, and 1 is the change in the oxidation state for one atom of carbon, but right here I have two atoms, so I'm multiplying it by 2. So you are getting the value as 2. Yes, you are getting the value as 2, and this 2 I'll be calling as the N2. And remember, guys, whenever you'll be having a substance in which the oxidation state of more than one element either increases or decreases, how do we calculate n factor of that substance? Let me tell you that n factor of that substance is always going to be mod of N1 plus N2, right? I got the value of N1, I got the value of N2, so it's going to be 1 plus 2, that means 3. So I'll say 3 is the n factor of this ferrous oxalate right here in this compound, yeah? Yes, RKBS, exactly. Yes, very, very simple it was, guys, okay? Whenever you will see a compound in which the oxidation state of more than one element either increases or decreases, you'll calculate its n factor. How? Simple, N1 plus N2, yeah? Yes? Yes? Wonderful. Let me move on. Let me give you a few more examples. You can easily calculate it. You can easily calculate, guys. You can easily calculate. First of all, if I want you guys to calculate the oxidation state of this AS right here, just crisscross these. Just crisscross these. It is going to be +3. It is going to be -2. Yes. What about the oxidation state of this AS right here? You can calculate it. X -8 is equal to -3. So you'll get the value of AS. You'll get the oxidation state of AS right here is +5. What about the oxidation state of sulfur right here? It is going to be +6. Yeah. Very simple. Correct. Now people understand. Oxidation state of AS is changing from +3 to +5. Oxidation state of sulfur is changing from -3 to +6. Can I say oxidation state of arsenic right here is increasing? Oxidation of sulfur also is increasing. Yes. So can I say this is the example of the compound in which oxidation state of more than one element increases at the same time? How do we calculate their n factors? Simply n factor of this compound is going to be n1 plus n2. So first of all, I need to calculate the n1 value. I need to calculate the n2. Then I'll add them up. I'll get the overall n factor. Yeah. Very simple. How do I do that? First of all, see. Let's check the change in the oxidation state of arsenic. See guys, this is the initial oxidation state of arsenic. This is the final oxidation state. Yes. So calculate the change. Final minus initial. Final value is +5 minus initial value is +3. The value you are getting as 2. Yes. 2 is the change in the oxidation state for one AS atom, but I have 2 AS atoms. So I'm multiplying it by 2. 2 2s are 4. So the value of N1 right here I got as 4. The value of N1 right here I got as 4. Yes. Yes. Now we will see from -2 to +6. What is the change? Final oxidation state, which is +6, minus initial oxidation state, which is -2. Can I say the value you are getting as 8? But 8 is the change in the oxidation state for one sulfur atom. But right here I've got 3 sulfur atoms. So I'm going to multiply it by 3. It's going to be 24. And this 24 will be the value of N2. You got the value of N1. You got the value of N2. So people, what is going to be N1 plus N2? 24 plus 4. That means 28. 28 is the n factor of this substance. If you got the n factor of this substance, just divide its molar mass by its respect to n factor. You'll be getting the equivalent mass. Yeah. Yes. Very simple. Okay. Yes. Thank you, Snehal. Is it 12? Oh, good morning. Good morning, guys. Good morning. Good morning. Yeah. Okay, let me give you a few more examples and let me see if I have a few more examples or not. Okay, I've got one more example, guys. You can check it out as well. This is Cu2S1. This is Cu2S1. Just crisscross these things. It's going to be +1. It's going to be -2. Yes. So over here, oxidation state is +2. Over here, oxidation state is +4. Absolutely. Is the oxidation state of copper increasing or decreasing? From +1 to +2. Oxidation state of copper is increasing. What about the oxidation of sulfur? Is it increasing or decreasing? It's increasing from -2 to +4. Yes. So I will say this is the example. This is the example in which oxidation state of more than one element is increasing. And how do we calculate its n factor? We already know that's going to be N1 plus N2. That's going to be N1 plus N2. So first of all, I need to calculate N1. Then I need to calculate N2. I'll just add them up. I'll get the value of what? I'll get the value of overall n factor. Yeah. Very simple. See guys, +1 to +2. What is the change? Final minus initial. Yes, final minus initial. Final is +2 minus initial is +1. You'll get the value as 1. So 1 is the change in the oxidation state for one copper atom. But right here I have 2. So I'm multiplying it by 2. So N1 value over here I got as 2. This is the value of N1. Now what about the value of N2? What about the value of N2? See guys, -2 to +6. Sorry, -2 to +4. -2 to +4. Calculate the change. Final oxidation state, which is +4, minus initial oxidation state, which is -2. You'll get the value of 6. You'll be getting the value of 6. Yes, 6 is the change in the oxidation state for one sulfur atom. And over here I'm only 1. So this is the value of N2. I got the value of N1. I got the value of N2. So N1 plus N2 is going to be 8. So 8 is the n factor of this substance. If you know its molar mass, divide that by 8. You'll be getting the equivalent mass. Yeah. Absolutely. Absolutely, guys. I'm sure this is clear to everyone. Yes. Talking about one more compound. Guys. Just first of all, get the oxidation state. Just crisscross these things. Crisscross these things. I'll say right here, the oxidation state of Bi is going to be +3. The oxidation state of sulfur right here is going to be -2. What about oxidation state of Bi right here? +5. What about the oxidation state of sulfur right here? Is it going to be 0? Yes, absolutely. Now people see, oxygen state of Bi is changing from +3 to +5. So oxygen state of Bi is increasing. Oxygen state of sulfur is changing from -2 to 0. That means oxygen state of sulfur is also increasing. Can I say this is the compound in which oxidation state of more than one element is increasing? How do I calculate its N factor? N1 plus N2. So first thing I need to calculate N1, then I need to calculate N2. I'll add them up. I'll get the value of overall N factor. Yeah. So let's check it out. Let's check it out. +3 to +5. What is the change? Change is final oxygen state minus initial oxygen state. You'll be getting the value as 2. 2 is the change in the oxygen state for 1 Bi. Over here I have 2 Bi, so I'm multiplying it by 2. So N1 value you got as 4. N1 value you got as 4. Similarly, -2 to 0. What is the change? Change is the final oxygen state, which is 0, minus initial oxygen state, which is -2. You'll get the value as 2. 2 is the change in the oxygen state for 1 sulfur, but over here I have 3 sulfur. I'm multiplying it by 3. You'll be getting the value as 6. So 6 is the value of N2. I got the N1, I got the N2. Can we calculate the N factor overall of this compound right here? Isn't it going to be N1 plus N2? Absolutely. Yes. N1 is how much? N1 is 4. N2 is 6. So 4 plus 6 is simply 10. So this is the N factor of this substance right here. If you know its N factor, you can calculate its equivalent mass. Yeah. Just dividing the molar mass by its respect to N factor. Let me know in the chat box if it's clear to everyone or not. Yes. Let me know in the chat box. Let me know in the chat box. Thank you, Yashwant. Yes. Guys, I'm not done yet. Wait, we have to talk about a lot of interesting things as well. Don't sleep off, okay? Don't sleep off at all. All right, moving on. Now. Till now, we talked about those substances in which oxidation state of more than one element was either increasing or decreasing simultaneously. Now we are going to talk about those substances in which oxidation state of one element will increase, another element will decrease. Yes. Now we are going to talk about those substances in which oxidation state of one element will increase and oxidation state of another element will decrease. Yes. How do we calculate its N factor? Simple. In the earlier case, we used to add the two, N1 plus N2. In this case, we are going to subtract that, right? In this case, we are going to subtract that. So N factor of the substance in which oxidation state of one element increases and another element decreases, you are going to calculate the N factor by the formula mod of N1 minus N2. Yes. So we need to get the value of N1, we need to get the value of N2. Once you have both the values, you can just subtract them. You can take modulus of it. You'll be getting the N factor. Very simple. How? Understand. See. First of all, get the charts, guys. Get the charts. Just take this 3 here. It's going to be +3. Just take this 2 here. It's going to be -2. Just this is the oxidation state of iron right here. This is the oxidation state of sulfur right here. Now check it out. Is the oxidation state increasing or decreasing? The oxidation state of iron is changing from +3 to +2. So the oxidation state of iron right here is decreasing. Yes. +3 to +2. The oxidation state of sulfur is increasing from -2 to +4. Yes. So I would say this is the example of the compound in which oxidation state of one element decreases and oxidation state of another element increases. Now people, now what do we do? I'll be calculating the value of N1 first. First, calculate the change in the oxidation state of iron. It is going to be final oxidation state of iron minus initial oxidation state of iron. Take the mod of it. You'll be getting the value as 1. 1 is the change in the oxidation state for one iron, but I have 2 irons, so I'm multiplying it by 2. You'll be getting the value over here as 2. 2 is the value of N1 right here. I'm calling this 2 as N1. Now what about N2? -2 to +4. Change in the oxidation state, which is going to be final oxidation state minus initial oxidation state. You'll be getting the value as 6. 6 is the change in the oxidation state for 1 sulfur, but I have 3 sulfurs, so I'm multiplying by 3. 6 multiplied by 3 is 18. So 18 is the value of N2. I got the N1, I got the N2. Just take the difference, just take the mod. I'll get the N factor of this substance as mod of N1. N1, how much I got? N1 I took as 2. N2 I got as 18. 2 minus 8 is -16. Take a mod. So it's going to be 16 is the N factor of this substance right here. Yes. This is going to be the N factor. Yeah. Okay. So very simple. If you got its N factor, you can calculate its equivalent mass. How? Simply by dividing its molar mass by the respective N factor. Okay. Yeah. Done. Talking about few more examples. Let me see if I have one more example. Okay, one nice example we have, guys. One nice example. People, do you remember in the last session I gave you the structure of this BaSCN whole twice? Do you remember that in the last session I gave you a structure? The structure was something like this. If you remember, in the last session of oxidation state, I gave you structure of this Ba. This was S, this was C, this was triple bond N, this was S, this was C, this was triple bond N. Yes, this is my BASCN, correct? Now we will see. First of all, do you remember, due to this triple bond, nitrogen was, first of all, nitrogen was more electronegative, and over here we have got a triple bond. So nitrogen was having -3 charge, carbon over here due to this triple bond will have +3 charge. We have discussed this in detail. What about this triple bond? Okay, nitrogen more electronegative, so nitrogen will have -3, carbon will have +3. What about this single bond? Sulfur is more electronegative and it's a single bond, so sulfur will get -1 and carbon will get +1 due to this single bond. Yes. What about this single bond? Sulfur -1, carbon +1. What about this single bond? Sulfur again -1, Ba +1. What about this single bond? Sulfur again -1, Ba +1. People, what is the net charge present on this Ba? It is +2. So oxygen state of Ba right here is +2. What about the oxygen state of sulfur right here? -1 -1 कितना हो गया? -2. So oxygen state of sulfur is -2. What about the oxygen state of carbon? +3 +1 +4. यहाँ भी +4. So oxygen state of carbon right here is +4. What about the oxygen state of nitrogen? It is -3, right? So oxygen state of nitrogen is -3. Okay, I got the oxygen states of each element right here. I got the oxygen state of each element right here. Ba +2, sulfur is in -2, carbon is in +4, nitrogen is -3. We have discussed this structure in detail in the last session where we discussed its oxygen states. Yeah? Yes? Yes? Yes, let me tell you if it's clear. Now people, at the same time, what about the oxygen state of this Ba right here? It is +2. What about the oxygen state of this sulfur right here? It is +6. Okay, what about the structure of HCN? Isn't it going to be HC triple bond N? Yes, people, due to this triple bond, nitrogen will have -3 charge, carbon will have +3 charge. Due to this single bond, carbon will have -1 charge, hydrogen will have +1 charge. Yes, because carbon is more electronegative than hydrogen. What about the net charge present on this nitrogen? Is -3. Oxygen state of nitrogen right here is -3. What about the oxygen state of this carbon right here? +3 -1. Isn't it going to be +2? Yes, +2. Very simple. Now people check. Now people check properly what all elements are changing their oxidation states. What all elements are changing their oxidation states? What all elements are changing their oxidation states? Just check it properly. Can I say the oxidation state of sulfur is changing from -2 to +6? So can I say the oxidation state of sulfur is increasing? Yes, -2 to +6. What about the oxidation state of carbon? Or what about the oxidation state of nitrogen? Oxidation state of nitrogen right here is -3, right here again is -3. Oxidation state of nitrogen is not changing. Oxidation state of nitrogen is not changing. What about the oxidation state of carbon? Oxidation state of carbon is changing from +4 to +2. Yes. Oxidation state of carbon is decreasing, oxidation state of sulfur is increasing. So this is the example of the compound in which oxidation state of one element is increasing and another element is decreasing at the same time. How do we calculate this N factor? Simply, I told you a formula. N factor of this compound is simply mod of N1 minus N2. So first of all, I'm going to calculate N1, then I'll be calculating N2. I'll take difference of these two. Yes. So very simple. See guys, -2 to +6, -2 to +6. This is the final oxidation state of sulfur. This is the initial. Final oxidation state is +6, initial oxidation state is -2, so the change is going to be 8. So this 8 is the change in the oxidation state for one sulfur atom, but I have got 2 sulfur atoms. Yes, so 8 multiplied by 2 is 16. So the value of N1 over here I got a 16. Yes, value of N1 over here I got a 16. Now what about the change in the oxidation state of carbon? This is the initial oxidation state of carbon +4. This is the final oxidation state of carbon +2. So final oxidation state of carbon minus initial oxidation state of carbon, just take the mod. Value you are going to get as 2. 2 is the change in the oxidation state for one carbon, but I have 2 carbons. I'm going to multiply it by 2. Value you are getting as 4. Yes. So people, I got the N1 value, I got the N2 value, and this is the compound in which oxidation state of one element is increasing and another element is decreasing. How do we calculate its N factor? Mod of N1 minus N2. N1 value, you got as 16. N2 value, you got as 4. Take the mod, value you are getting as 12. So 12 is the N factor of this substance right here. If you got its N factor, you are going to divide the molar mass of this substance by its N factor. You'll be getting the equivalent mass. Let me know in the chat box if it's clear to you. Let me know in the chat box if it's clear to everyone. Hit the chat box fast so that I can move ahead and talk about few more interesting things. Yeah. Yes. Priya is saying, sir, I am yawning, but it's interesting. That's great. That's great. You're sacrificing your sleep. That's wonderful. Even I'm doing the same for you guys, yeah? Wonderful, guys. Okay, moving on. Moving on. N factor for disproportionation reactions. First of all, what are disproportionation reactions? How do we calculate the N factors, yeah? How do we calculate the N factors for disproportionation reactions? I'm not giving you the general procedure. I'll simply tell you a trick by means of which we can calculate the N factor of different substances which undergo disproportionation, which you already must be knowing as well, yeah? Very simple. That's the common trick, yeah? See, guys. If I'll ask you what is the oxidation state of this Br right here, it's going to be 0. What about the oxidation state of this Br right here? BrO3 negative, so it's going to be plus 5. What about the oxidation state of this Br right here? It is Br negative, so minus 1. Yes. So oxidation state of Br right here in this part is increasing from 0 to plus 5. Oxidation state of Br in this part is decreasing from 0 to minus 1. So can I say from 0 to plus 5? From 0 to plus 5, oxidation state of bromine is increasing. From 0 to minus 5, oxidation state of bromine is decreasing. Increase in oxidation state is what we call as oxidation. Decrease in oxidation state is what we call as reduction. Can I say some part of this Br2 is undergoing oxidation and some part of this Br2 is undergoing reduction? So I would say that compound whose some part will be undergoing oxidation, whose other part will be undergoing reduction, this compound we say is undergoing disproportionation. Disproportionation, yeah? So this Br2 is right now undergoing proportionation. Okay, sorry. Guys, what is the spelling for disproportion? I forgot. Disproportionation. Tionation. Is that? Disproportionation. Okay, fine. All right. See, guys. I'll say in this part the oxidation state of bromine is changing from 0 to plus 5. So oxidation state of bromine is increasing, and in this part the oxidation state of bromine is decreasing. So can I simply say some part of Br is undergoing, some part of this Br2 is undergoing oxidation, some part of Br2 is undergoing reduction. That substance whose some part is undergoing oxidation, whose other part is undergoing reduction, we say that compound undergoes disproportionation. Yes. Yes. Now people see. Now what I'll be doing? Again right here, I'll be calculating the value of N1, I'll be calculating the value of N2. Let's get to know N1, N2. Let's get to know N1, N2 first. See, from 0 to plus 5, what is the change? Change is final oxidation state minus initial oxidation state, that is 0. Just take the mod of it, you'll be getting the 5 value. But 5 is the change in the oxidation state for 1 bromine, but I have 2 bromine, I'm going to multiply it by 2. So N1 value I got as 10. N1 value I got as 10. Yes. Now similarly N2 value 0 to minus 1. 0 to minus 1. What is the change? Change is the final oxidation state, which is minus 1, minus initial oxidation state, which is 0. So the change is 1. 1 is the change in the oxidation state for 1 Br, but over here I've got 2 Br. I'm going to multiply it by 2. The value is going to come as 2. So people, I got the N1 value, I got the N2 value. Remember, whenever you'll be having any substance which will be undergoing disproportionation, how do we calculate N factor of that substance? N factor of that substance is simply N1, N2 divided by N1 plus N2. N1, N2 divided by N1 plus N2. People, I got to know the value of N1. How much is that? That is 10. I got to know the value of N2. That is 2. Yes, divided by 10 plus 2. Isn't it going to be 20 divided by 12? 20 divided by 12 means 4, 5, 4, 3. So 5 by 3 is going to be the N factor of this Br2 right here. If you got its N factor, you can calculate its equivalent mass by simply dividing its molar mass by its respect to N factor, which is 5 by 3. Yes, absolutely. Let me give you one more example, guys. Let me give you one more example. See, this is one more example which I have right here. P4, its oxidation state right here is 0. pH3, its oxidation state of phosphorus right here is minus 3. What about the oxidation state of phosphorus right here? It's going to be plus 1 multiplied by 2 plus x plus 2 multiplied by minus 2 is equal to minus 1. Yes, is equal to minus 1 because charge present on it is minus 1. So it's going to be plus 2 minus 4. Minus 4 plus 2. Minus 4 plus 2. That means minus 2. Yes, that means minus 2. So minus 1 plus 2. It's going to be plus 1. The oxidation state of phosphorus right here is plus 1. Yeah, you can do it. Yes, very simple. Now people understand. Oxidation state of phosphorus right here is decreasing from 0 to minus 3. So oxidation state right here is decreasing. Yes. So in this process, this P4 is undergoing reduction. What about the oxidation state of this? Just a second. What about the oxidation state of phosphorus right here, it is +1, right? So oxygen state of phosphorus right here in this process is changing from 0 to +1. So oxygen state of phosphorus right here is increasing. Increase in oxygen state is what we call as oxidation. Can I say during this process P4 is undergoing reduction, during this process P4 is undergoing oxidation? So or I can say like this, some part of P4 is undergoing reduction, some part of P4 is undergoing oxidation. So I would say in general P4 is undergoing disproportionation. Yes, P4 is undergoing disproportionation. If P4 is undergoing disproportionation, how do I calculate its N factor? It's going to be simply N1 minus N1 multiplied by N2 divided by N1 plus N2. Yes? Yes. Now the point is, how do we calculate N1? How do we calculate N2? Very simple. How do we calculate N1? How do we calculate N2? See guys, N1 value is 0 to -3. What is the change? Change is final oxygen state minus initial oxygen state. This is final, this is initial. Take the mod, value you are getting as 3. This 3 is the change in the oxygen state for 1 phosphorus, but I have 4 phosphorus, I'll multiply it by 4. So 3 4s are 12. So N1 value guys you got as 12. N1 value you got as 12. Yes, N1 value you got as 12. Now let's talk about N2 value. From 0 to +1. From 0 to +1. Change is final oxygen state minus initial oxygen state. Value you are getting as 1. 1 is the change in the oxygen for 1 atom of phosphorus, but I have 4. So I'm multiplying by 4. So N2 value I got as 4. I got N1, I got N2. N1 I got as 16. N2 I got as 4. N1 I got as 16. N2 I got as 4. Is that? Sorry, not 16, 12. Yeah? See guys, N1 I got as 12, N2 I got as 4 divided by 12 plus 4. This is going to be 48 divided by 16. 48 divided by 16 simply means 3. So 3 is the N factor of P4. If you got the N factor of P4 right here, you can calculate the equivalent mass of P4. How? Simply by dividing its molar mass by its respect to N factor. Yeah? We can do that. Yes? 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 Absolutely. Done, 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 done. Yes. Okay. Moving on. Let me give you one more reaction. And I'll be needing the answer of that question in the comment box afterwards. Once the session ends, I want the answers, okay? Just invest 5 minutes. Once the session ends, invest 5 minutes of your time. Just do that question and let me know the answer in the comment box. And I'm going to actually check the names of the ones who are going to answer the question properly, okay? The question is like this, for example, calculate the equivalent mass of H2O2 of hydrogen peroxide in the following reaction. And reaction is given to me as H2O2 gives H2O plus O2. Let me know the equivalent mass of this H2O2 right here. Simple, calculate its N factor, divide its molar mass by the N factor, and let me know its equivalent mass in the chat box, in the comment box once the session ends, okay? Yes, Yojana, I'll be teaching organic too. You don't worry about that. I'll be doing that. Then there are few more topics remaining. I'll tell you. We have to cover redox titration here. We have to cover acid-base titrations here. Yes, we have to cover equivalent concept. Equivalent concept actually same होता है redox titration. ठीक है? उसमें equivalent concept भी होगा. ठीक है? Wonderful guys. Okay, so with this, I'm ending today's discussion. Yes, I hope you guys would have enjoyed this session. I'm damn sure about that because today's session was all about concepts. It was all about concepts, right? I taught you in detail how do we calculate N factors of different substances, how do we calculate equivalent masses. Yes, we talked about it in detail. I'm sure you are going to kill every question. Whatever question is going to come from the N factor part, you are going to kill that, I'm sure, right? For the ones who joined me late, let me tell you, we are starting with the NEET 2021 crash course on the actual Vedantu platform. So if you guys are interested in getting trained by the master teachers of Vedantu through the actual Vedantu platform, okay, we are going to cover everything, your whole syllabus before your NEET 2021 examination. Okay, if you're interested, you can join the batches. We have already started the batches. On every Monday we start a new batch. Okay, if you are interested, you can actually go to the link which is there in the description box of the video. Click on that link, use the coupon code as WSNET. After using this coupon code of WSNET, you guys are going to get 20% off right here, and you are getting this crash course, guys, for just 8,000. okay, and your exam will be in April, May, something like that. So till then, it is basically a span of December, January, February, March. Okay, for 4 months we are going to cover everything. For 5 months we are going to cover your whole syllabus for the upcoming NEET 2021. So if you guys are interested, if you want to get personally trained by us, by the actual Vedantu platform, you can join the platform. Okay, and let's kill it together. Yeah. Yes, and people, there is one more link in the Telegram, in the description box, that is for the Telegram group. Click on that link as well. Get added to the Telegram group and stay updated about the classes as well, right? And at the end, do not forget to like the video, share the channel and subscribe at the same time, so that everyone will get benefited out of these sessions. So people, this was all from my side in the today's session. I'll see you guys again tomorrow. Till then, you guys take care. Bye-bye. God bless you all and love you all. Take care, guys. Bye.